Hello students, in continuation to chapter number 3, matrices and determinants of class 12. Today in this video we are going to learn about how to find A inverse, and using that A inverse we have to further solve the system of equations, right? So the question will be like, if a matrix A is given to you where you need to find A inverse, and hence using this A inverse you have to solve the system of equations given to you. So let us see how to solve such questions in which you cannot apply the method in which we take a system is given by Ax equal to B, and then we will find the solution as x is equal to A inverse B. Firstly, you need to solve this determinant and then find A inverse, and hence use that A inverse in solving this system, right? So let us see how to solve such questions. Now in these type of questions, one important thing to understand is this: we cannot solve this system of equations given to you directly. Okay, firstly we need to solve this A for finding A inverse. So A inverse will be calculated by using A inverse is equal to 1 upon determinant A into adjoint A, right? And then we need to establish a connection between this matrix given to you and the matrix that we will obtain from this system as the coefficient matrix, right? So then that inverse accordingly will be used to solve this system, right? So let us start. So we know to find A inverse we need 1 upon determinant A into adjoint A. So firstly we will compute the determinant. So determinant here is 2, 3, 1 minus 3, 2, 1, and it is 5 minus 4 minus 2. So which is your 2, and this is minus 4 plus 4. This is minus of minus 3, that is plus 3, and it is your minus 6 plus 4, and this is 5, and this is 3 minus 2, right? So 5, this is 3 minus 2. So it becomes 0, and it is, from here I'll get minus 2, so minus 6 and plus 5, which is equal to minus 1, which is not equal to 0. So my A is non-singular, as we know. Why? Because determinant A is not equal to 0 here, right? So A inverse will exist, which can be calculated by your A inverse is equal to 1 upon determinant A into adjoint of A, right? So this is my A inverse. So for this, firstly I need to calculate my adjoint of A, which will be obtained by replacing all the elements by the corresponding cofactors and then taking its transpose, right? So let us start taking the cofactors. So this is C11, C12, C13. So this sign will be negative, right? So let us take out the cofactors. So for 2 it is minus 4, and this is plus 4. So it becomes 0. So here it is 0. C12, negative sign is already there. So it is minus 6 plus 4, which is your 2. So I'll get 2 here, right? And then next is your C13. C13 is your 3 minus 2, that is 1. So this is how we replace the corresponding cofactors. So let us do quickly for C21, C22 and C23. Quickly, this sign will be negative, this will be negative, right? So let us start calculating, and it becomes your, for 3 it is 6 minus 5, that is 1, and it will be minus 1 here, right? For 2 it is minus 4 minus 4 minus 5, that is your minus 9. So this is minus 9. For minus 4 it is 2 plus 3, that is 5. So as the sign outside is minus, so it is minus 5. For C31, C32 and C33, so this will be negative. So this will be your 4 3s are 12 minus 10. So 12 minus 10 is 2. Okay, so this is 2 here. For this it is minus 8, minus sign is already there, and this is your -8 and -15. So I'll get 23. Overall result is 23. And for the last one, I'll get 4 and plus 9, which is equal to 13. Right? So this is the adjoint matrix yet to be obtained by taking the transpose. So after taking the transpose, it will be your 0, 2, 1, -1, -9 and -5, and then it is 2, 23 and 30. Okay, so now A inverse is equal to 1 upon determinant A into adjoint of A. So determinant A was -1, so it is 1 upon -1, and adjoint A that we calculated recently, 0 to 1, -1, -9, -5, it is 2, 23 and 13, right? So adjust the negative sign. So it is -2, 9, -23, -1, 5 and -13. Now let us come back to system. So given system of equations is, let us write the equations. So it is 2x minus 3y plus 5z equal to 11, 3x plus 2y minus 4z equal to -5, and x plus y minus 2z is equal to -3, right? So we know it can be written as. So let us not predict whether it is of the form Ax equal to B or not, because I have to see whether my coefficient matrix is A or A transpose. So it is 2, 3, 1, -3, 2, 1, and it is 5, -4, -2. This is the coefficient matrix, and this is the variable matrix, and this is my constant matrix, right? So clearly we can see that it is of the form Ax equal to B. So it is of the form Ax equal to B, right? Now, as clearly we know that for this matrix A, we already calculated the determinant, and determinant A is not equal to 0. That means the given system is consistent and is having unique solution. So unique solution for such system is given by Ax equal to B, and its solution is given by x is equal to A inverse B. So x is my variable matrix. A inverse we calculated right now. So 0, -2, -1, 1, 9, 5, -2, -23, -13, and B is the constant matrix. So let us multiply. So I'll get it as 0, -5 plus 6, it is -22, -45 plus 69, -11, -25 plus 39. So the overall result here is 1, here it is 2, okay, here it is 3. So definitely x is my x, y, z. The values of x is 1, y is 2, and z is equal to 3. Let us confirm whether my result is true or not. So I'll put it in any of the equations. So let's go for the third one. So it is x plus y minus 2z. So this becomes 1 plus 2 minus 3 to 6. So this becomes 3 minus 3, which is -3. And say this is my right hand side. So this solution is correct. Let us take one more example. And this is if A is 1, -2, 0, 2, -1, -1, 0, -2, and 1, find A inverse and hence solve system of equations given by your x minus 2y equal to 10, 2x minus y minus z equal to 8, and minus 2y plus z is equal to 7. Okay. So let us see and start with determinant of A. So 1 minus 2 0, 2 minus 1 minus 1, and this is your 0 minus 2 and 1. So let us find the determinant first. So it is minus 1 and minus 2, and this is minus 2 times this is minus 2 and minus 0. So this is minus 3, right? And it is plus 4. So result is 1, which is not equal to 0, right? So we can simply say A is non-singular, that is determinant A is not equal to 0, implies A inverse exists and is given by adjoint A upon determinant A. So firstly we need to frame the adjoint matrix. Okay, so let us frame the adjoint matrix. So again, adjoint of A will be the matrix obtained by replacing each element by the corresponding cofactors and then taking its transpose. Okay, so this is your, so this sign I'll take negative. So let us start. This is minus 1 and minus 2, that is minus 3. Okay, for this it is minus 2. So minus of minus 2 is plus 2, and for last it is your 2. Okay, so I get the first row as minus 3, 2 and 2. Okay, so let's go for 2 1, 2 2, 2 3. So this is negative, this is negative. Okay, so 2 1 it is 2, it is minus 2. For this it is 1, and for the last one it is minus 1. So minus of minus 1 is plus 1. So second row here is minus 2, 1 1, then 3 1, 3 2 and 3 3. So this is your minus 4. Okay, so this becomes your minus 4. For second one it is minus 2. So as already the sign here is minus due to this odd powers, the result is 2. And for 1 3 it is minus 1. It is minus 1 and plus 4, which is your 3. So the second row is minus 4, 2 and 3. Now let's take its transpose. Minus 3, 2, 2, minus 2, 1, 1 and minus 4, 2, 3, which is the required adjoint, right? Now let us see my system. So given system is, and I would suggest you that you first in such kind of questions write the coefficient matrix. See here x is 1, okay, then it is 2 here, and in the third equation no x is there, so it is 0. For y it is minus 2, okay, this is minus 1 in the second equation, and in the third it is minus 2, and for z in the first equation it is 0, here it is minus 1 and this is 1, and the variables are x, y, z, and the constant one is 10 8 7. Now view this system carefully. Either I told you it is of the form of Ax equal to b, or it will be equal to A transpose x is equal to b. Okay, so frame A transpose here in this matrix. What will be my A transpose? It will be 1 2 0. Interchange the rows and columns. It is minus 2 minus 1 minus 2 and 0 minus 1 and 1. So carefully see that we are not getting here the system as Ax equal to b, but the system is of the form A transpose x is equal to b, right? A transpose x is equal to b, which is also invertible. Now why? Right? It is also invertible because the reason I know that my determinant of A is same as determinant of A transpose. So determinant of A was 1, which was not 0. So determinant of A transpose is also equal to 1, right? So that means A inverse is existing, right? But how to establish the connection between this A inverse? Now here I will find my this thing implies that A transpose is also invertible, right? And it is given by that A transpose whole inverse will be same as A inverse whole transpose, right? So this result holds here. So my result will be X is equal to, solution is given by X is equal to A inverse, which I calculated right now, this A inverse whole transpose into B. So I have to take the transpose of this inverse, which I'll compute from this matrix. Okay. So after adjoint, I'll compute the inverse and that inverse will be utilized here, right? So what will be my A inverse? Firstly, I compute my A inverse here. So my A inverse is 1 upon determinant A is 1 upon 1 and adjoint to the matrix I obtained here, minus 3, 2, 2, minus 2, 1, 1, and it is minus 4, 2 and 3. So it itself is the A inverse. But here I need to take the transpose of this. So A inverse whole transpose into B. Okay. So as X is your A inverse whole transpose into B, so my A inverse here was minus 3, minus 2, minus 4. It is 2, 2 here, 1, 1 and 2, 3. Okay. And B matrix was 10, 8, 7. So I need to take its transpose. The inverse I calculated. So it will be like minus 3, minus 2, minus 4. So it is 2, 1, 2 and it is 2, 1, 3 into 10, 8, 7. So the overall result is going to be minus 30 plus 16 plus 14. Okay. And it is minus 20 plus 8 plus 7. It is minus 40 plus 16 plus 21. So this result is going to be 0. Minus 30 plus 30 is 0. And this is your minus 5. And this is your minus 3. Okay. So X, Y, Z. X here is 0. Y is minus 5. And Z is minus 3. So let us reconfirm from any of the equation. X minus 2y is equal to 10. This was the first equation. So X is 0 minus 2 into your minus 5. Okay. Is equal to, yes, 10 is equal to 10. So it is verified that this result is true. Okay. So just we need to be a bit careful in observing the system in such questions. If it is of the form Ax equal to B, this thing implies X is equal to A inverse B is the required solution. And if it is of the form A transpose X equal to B, this thing implies X is equal to your A inverse whole transpose into B is the required solution. In this way, we can use the already computed A inverse to solve our given system of equations.